I have spent a considerable amount of time on the Shadow platform recently, and for the average user, their service is an excellent alternative to sinking money into an average computer. Now, I've had many issues with their service in the past, but today we're going to be looking at the Shadow Infinite, and my goodness, this is going to be a game changer. Hey guys, Turk here. I hope you're having a fabulous day. Shadow is a virtual desktop experience that enables their subscribers to access dedicated server hardware on the cloud and stream the desktop experience to their local device. I have covered their service basics in other videos, so I definitely recommend checking out the playlist in order to catch up. Shadow's Boost service is a decent 1080p experience for most games, but I did say in my previous review there were several shortcomings with the hardware that left a bad taste in my mouth. Throughout 2020, they have been trying to keep up with an influx in activations, but guys, here in late 2020, they have dropped a bombshell. Shadow is starting to roll out their next 2 levels of hardware tiers in their service to current subscribers, and I have been blessed to test out their Shadow Infinite service. Full disclosure, this is not a sponsored video, but Shadow has provided me with a short-term trial to evaluate their latest upgrades and see what they can do. Though their hardware is based on custom enterprise server solutions, the experience is frankly right on par with the latest hardware available for consumers. Let's break it all down now, shall we? For a CPU, we're getting a 2-core bump from their Boost service with access to half of an Intel Xenon W3235 processor, which has a base clock speed equal to the effective boost clock of their entry-level service. And in my testing, when I was running Cinebench on multi-cores, I was boosting up to 4 GHz, which is a surprisingly on par with our latest favorite Ryzen processors. We're also getting a massive bump in memory capacity as well, moving from 12 GB of 2133 up to an astounding 32 GB of 2933 in a hex channel configuration. This kind of capacity would even make tech deals blush. But what's most critical about the enhancements in the service is access to NVIDIA's mid-tier Quadro RTX GPU, the RTX 6000. Now, on paper, it's on par with the RTX Titan, with impressive CUDA core counts and gobs of VRAM. This leap in graphics horsepower is nearly double that of a once proud GTX 1080. Couple that with RTX compatibility, and there are plenty of opportunities for this machine to shine. Less impressive is the storage. In my last review, I called out that Boost storage was just not sufficient for a gamer in this day and age. With Infinite though, we do have 256 gigs of SSD storage for our OS and other critical applications, but we also have an additional 768 gigabytes of hard disk storage that's likely stored somewhere on another storage appliance. Though this configuration is not ideal for some games that really, leverage a lot of streaming from storage into RAM, the capacity alone is enough to hold my entire test suite for my testing today. As always, requesting additional storage is as easy as logging into your account and making the request for an additional fee, of course. Now, for the rest of the system, we are stuck behind the enterprise environment, but according to Shadow, their data center runs between 20 degrees and 22 degrees Celsius for their ambient temperature, and of course, really loud fans and server-grade airflow. Since Shadow has stacked their spec sheet, I have to dust off my latest test bench and I have to make a direct comparison. No more $600 budget builds today, my friends. We're going to be throwing it all at Shadow. My test bench consists of our previously reviewed Ryzen 9 5900X with 16 gigabytes of 3600 memory, and my RTX 2080 Super and my recently acquired RTX 3080 GPU. Stacking the systems side by side, guys, I am just shocked with just how much power this virtual desktop experience can deliver. But what kind of performance should we expect? Let's get basic computing out of the way first. PCMR is my standard sanity check, and the Infinite service provides anywhere between 12% and 68 percentage points improvements over their introductory Boost service. With 3DMark, we start to see just how this combined CPU and GPU improvement can intend to scale as we crank up the FPS. Firestrike sees 65% improvement with the GPU score, Firestrike Extreme sees 78%, and guys, TimeSpy, it sees an impressive 110% improvement. Our final application benchmark is going to be Cinebench, and the improved architecture and an additional 4 threads from the Xenon processor propel the Shadow Infinite to an impressive 86% improvement. But does this all translate into gaming performance? When we tested Shadow the first time, we selected a small subset of games to particularly hammer the CPU and the GPU. I've retested my local hardware and the Infinite service with GTA 5, Rainbow Six Siege, Red Dead Redemption 2, and Shadow of the Tomb Raider. If there are any other games that you would like to see, just hang tight. This is just the tip of the iceberg today. GTA 5 is a classic example of a CPU bottlenecked game, and even the increased processing power of the Shadow Infinite service grants us an additional 20 FPS at both 1080p and 1440p. Clearly, the desktop processors have the superior horsepower, but guys, when we're driving around the city of Los Santos at 120 FPS, it's really hard to complain. Rainbow Six Siege is not an issue for any of the platforms today, though it is really interesting to see 200 plus FPS coming from our virtual desktop experience. Note, if you want to know how the games handle, I've got a video covering just that, and I'll likely do a similar video with more recent games. Red Dead Redemption 2 continues to show just how impressive the improvements are when surpassing the older Shadow tiers. Still, it's unfortunate that the RTX Titan equivalent cannot keep up with the RTX 2080 Super. With Shadow of the Tomb Raider, we get our glimpse of why Shadow's Infinite tier starts to stumble a bit. The gray bars in this chart show just how powerful the RTX 6000 GPU can be when it comes to rendering frames, which it does outclass the RTX 2080 Super. Unfortunately, the overall frame rate does come crumbling down due to the clock speeds driven by the Xenon processor. This is by no means a loss for the Shadow, but it does show some of the hardware's limitations. For a standard review, this would be the end of Shadow's coverage, and I would give this a modest recommendation to anyone that feels that they can tolerate the latency that comes with the platform's inherent latency. But I have been collecting a lot of data with ray tracing over these past few months in order to prepare myself for the RTX 3000 and AMD 6000 series GPU launches. Now, rather than let that data go to waste, guys, I present to you my RTX benchmarks. So long, Shadow Boost. It's time for the real hardware to play. Let's go. Starting us off with the Minecraft RTX beta, we have limited accessibility to RT options, and when we go into full screen mode, the default is to go to our standard desktop resolution. Our map here is Portal Pioneer's benchmark mode. Regardless of the massive performance hit when we go to full path tracing, our RTX 6000 series performance is outpacing even our RTX 3080, and I really don't understand that, though it is repeatable on subsequent reboots. The game is still in active beta, however, and Mojang's updates could be impacting, driver level fixes and vice versa. Quake 2 RTX takes another classic game and enables fully path-traced graphics. Our results seem to be more adequately representative of reality here, with the RTX 6000 performing better than the RTX 2080 Super, and it barely misses 60 FPS at 1440p. Maybe if we switch to low on the global illumination setting, we will get past that limit. As we saw in our Will It 4K video with Crysis Remastered, the game is marginally playable at lower frame rates, and I think it really is best played on Shadow Boost with 1440p low settings for a 60 FPS experience. Now, with Infinite, we can get much better frame rates at higher detail levels and settings and resolutions. On the one hand, we appear to be CPU limited here, but fortunately at 4K, the RTX 6000 can stretch its legs a bit better. If you're going for 30 FPS, Shadow Infinite can dominate 4K gameplay. But at 60 FPS with the highest detail settings, Shadow only hits that goal with 1080p. Control is arguably one of the better implementations of ray tracing and DLSS, and having access to all of the knobs gives us the ability to optimize for performance. For my benchmarks today, I'm using Digital Foundry's recommended settings, and I'm going to be standardizing my setup for all of my benchmarks. Looking at 1080p, we see mixed results, with the 2080 Super surpassing standard quality as well as DLSS. From there, 1440p and 4K land about where we would expect it. However you spell it though, 1440p with DLSS turned on achieves playable frame rates in the hallway of doom. Of course, with RTX turned on. Rounding out the standard RTX gameplay charts is Shadow of the Tomb Raider. Here we are going to be sticking to the highest detail settings, and we're going to be engaging Ultra RTX shadows along with DLSS. We can nearly get 4K running at this demanding setting on Shadow, but we do miss a few FPS. Compared to the 2080 Super based system, Shadow Infinite is looking really good. If you've been following me on Twitter and on Twitch, I'm proud to say that Cyberpunk is here, and I am thoroughly impressed with how it performs. Having played through Act 1 entirely on Shadow at 4K, I am amazed with how well this system runs. With bitrate set to the max, this game looks phenomenal. But that performance does come at a cost, and we did hit a few bumps along the way. Now suppose you're planning on playing Cyberpunk on your new and shiny Shadow instance. If that's the case, you're definitely going to need to pick up the latest Quadro new feature branch drivers in order to gain the optimizations that come from the GeForce line, and these drastically improve the DLSS performance. I noticed several inconsistent graphical performance issues, especially at 1440p with the RTX features turned on. With the 1.04 Cyberpunk update and the latest Quadro drivers, 4K runs like a dream. Here's the chart. My benchmark run is executed in Act 1 once you finally have access to the car, and driving down a hilly, active street puts an impressive strain on the GPU, and it actually cripples the CPU on the Shadow platform. At 1440p, I saw many instances where the GPU was stuck right around 60% utilization, but when we go into 4K, we do continuously hit utilizations around 90%. As this game has only just come out, I'm still testing the 3080 on my local machine, but with my RTX 2080 Super, it is a much more fluid experience on the local PC. This is similar to what we encountered on our Crysis playthrough. I would bet that the performance behavior that we're observing here from Control would replicate in this instance, where the 2080 Super is slightly behind at the 4K resolution. Shadow Infinite is a massive step forward for the service and their platform, but there are definitely pros and cons to consider before jumping into the virtual desktop experience. First is the graphical quality. With Shadow, you can adjust your streaming bit rates in order to accommodate your specific network situation, and unfortunately, this does directly impact your visual quality. For recording, I was playing at a constant 70 megabits per second on my fiber internet connection. That uses roughly 28 gigs of data per hour, yikes. If you turn the bitrate down too low, about 30 megabits in my estimation, the graphical quality you gain from the service is lost due to the stream's compression. You still maintain the frame rates as listed in this video, but the quality is reduced, which actually, you can lower down your quality settings then and increase your frame rates. If you'd like me to compare that setup, let me know down in the comments. Next is latency. In my previous video, I've addressed that as long as you're not playing latency-sensitive games such as extremely fast-paced shooters, most games are quite tolerable with the Shadow service. As I was driving around Night City, I constantly kept having to remind myself, remember Turk, you're playing this from a data center that is hundreds of miles from where you live. So my recommendation would be to try out the Shadow Boost service for a month and see if your network situation works. Lastly is the hardware. We continued to hit processor limitations several times in our benchmarks today, which seems to continue to be a sticking point using enterprise-grade hardware in a desktop use case scenario. There are a couple of Xenons out there that do have higher clock speeds, but they do sacrifice cores for clocks. Regardless of the potential of the RTX 6000, it almost seems like it's overkill. Maybe an RTX 5000 or 4000 would be a better choice for a wide-scale deployment. Storage capacity is a great leap forward, though with the reduced costs in SSDs in recent months, maybe it's time to finally abandon the spinning disk arrays in favor of high-performance SSDs. Guys, time for some good news. As of the time of this recording, Shadow Infinite costs $40 a month. That might seem a little bit steep, but let's break it down. Let's say you plan on having the subscription for 2 years. That's going to be costing you just under $1,000 USD. Building up a comparable system with the latest GPU that matches our system's performance today, it can cost right around $1,350 USD. Break that down to 24 months and you're looking at right at $56 a month. Let's not forget, GPUs are incredibly hard to come by right now. According to Shadow, US activations take between 1 to 2 months to fulfill, while they are still really backed up in Europe. If you're willing to wait that long, Shadow Boost might be a good stopgap to get you by. If you were hesitant to drop $500 on a GPU, another angle would be to spend $40 and actually rent an RTX 6000 and just see what RTX is all about. There are no contracts, so just give it a spin. For more up-to-date information regarding activations, check out the links in the description. Overall, I'm happy to say that Shadow has brought the best hardware to the table, and it does put local desktops on notice as they continue to push the envelope of their infrastructure and streaming technologies. Sure, there are some shortcomings that come with their solution, but the hardware is definitely capable of bringing a top-shelf gaming experience to anyone who has a decent internet connection. Though I prefer a local desktop for my gaming experience, Shadow is a great alternative. Thank you everyone for sticking to the end of the video. I appreciate all the support that you have brought to our channel. Drop a comment with what impressed you the most about the Shadow platform today. If you have any other ideas or questions regarding the service, maybe we can talk Shadow into giving us another month of service. Links in the description if you guys want to talk to me on Discord, Twitter, or check out my Twitch page. As always, thanks for watching. Stay classy, Turk Force.